All right, so the following question reads, on the basis of an examination, 9 students, F, G, H, I, J, K, L, M, and N, are each placed in one of 3 classes. The 3 highest scorers are placed in the level 1 class. The 3 lowest scorers are placed in the level 3 class. The remaining 3 are placed in the level 2 class. Each class has exactly 3 students. Okay, so at first glance, this seems like a very simple grouping game. We have 3 different classes, and each class has 3 students, totaling 9 students. So let's draw this out. We have our students, F, G, H, I, J, K, L, M, and N. We have our 3 classes. We know that each class has 3 students in it. 1, 2, 3. And we've ordered them from highest scores to lowest scores, so they're going to be ranked 1 through 9. 4, 5, 6. And the last 3 are going to be in class 3, 7, 8, and 9. All right, so far that seems totally fine. Now, before we begin to diagram the rules, I want you to take a moment and notice something very important about the rules. Every single one of the rules is a pure sequencing rule, meaning that every rule has an inherent order in it. If you look at rule number 1, we have I scores higher than G. Rule number 2, G scores higher than both J and K. Rule number 3, J scores higher than M, and so on. All 6 of the rules are pure sequencing rules. Now, having 6 pure sequencing rules poses a problem with the way that we've drawn our setup. And I'll show you for example. Let's diagram rule number 1. Rule number 1 says that I scores higher than G. Okay, well, we know that means I is going to be to the left of G. Okay, so normally what we would do now, we're going to get into our quote-unquote not rules. So that means that G cannot be in first place. Why? Because I has scored higher than G, so if G is first, then there's no place for I to go. Similarly, I can't be in 9th place, because if I were 9th, there'd be no place for G to go. Now we have 6 rules that are similar to this that have not rules in them. And we only have this small little space between each class to write out all of our not rules. That is conducive for a very messy game. And the way that we've currently drawn out our setup isn't visually efficient. And what I mean by that is, if you look, we see here our 3rd student. That 3rd student has scored immediately higher than our 4th student. But it's hard to see that this way because they're diagonal from each other as opposed to being immediately next to each other. So, since we have a grouping game that has an element of ordering in it, that means we are dealing with a hybrid game. And as you should know from experience with hybrid games can tend to have some off-kilter setups, which means even though we have these 3 groups, it's going to be better for us if we draw this out linearly as opposed to delineating our 3 different groups. That way, we'll be able to better write out all of our quote-unquote not rules, and you'll have a better visual experience of seeing how each student relates to each other. So, let's redraw this. We know that we have 9 students, and we know that the first 3 are going to be placed in the first class, and the last 3 are going to be placed in the 3rd class, and then the remaining 3 are going to be in the 2nd class. So in this way, we've diagrammed out both the linear order and the different groups. So before we get into the rules, I just wanted to point out, you saw that we first drew the setup one way, and then when we saw how the rules were written out, we made the decision to rewrite the setup in a more efficient way. Why? Because drawing your setup in the most efficient way is the key to not only mastering accuracy on the logic games, but also mastering your timing. And you'll see that the way we've written this out is going to be conducive not only to answering the questions more accurately, but to answer the questions very quickly. All right, so now finally, let's go ahead and diagram the rules. Rule number 1, I scores higher than G. All right, so this is our second go on rule number 1. I scores higher than G. That means that G is not going to be first, and I is not going to be ninth. Rule number 2, G scores higher than both J and K. Okay, so G higher than J and K. That means that J is not first and K is not first, and that means G is not ninth and G is not eighth because G has 2 people scoring lower than him. And we can actually combine rules 1 and 2. Like so, we can have I is to the left of G, and then rule number 2 tells us that G is to the left of both J and K. So now you see that J and K have 2 people scoring higher than them, meaning J and K cannot be second either. Likewise, I now has 1, 2, 3 people scoring lower than him, so that means that I cannot be 9th, 8th, or 7th. Now, rule number 3. J scores higher than M. Okay, so J to the left of M. That means M is not first. That means J is not last. And now we can combine this with our large chain. J is to the left of M. So now we see that M has J, G, and I before it. Now don't make the mistake of thinking that K must be before M. As you can see, K and M don't have a relationship. So this means that only 3 people at this point are going to be to the left of M for certain. So that means that M cannot be first, second, or third. Likewise, now I has 1, 2, 3, 4 people scoring lower than him. So that means I cannot be 9th, 8th, 7th, or 6th. We know that G now has J, K, and M scoring below him. So that means G cannot be 9th, 8th, or 7th. And now we're ready to go to rule number 4. M scores higher than H. Okay, so that means that H can't be first and M cannot be last. Now we can connect this to our large chain. M is before H. So as you can see, we have 1, 2, 3, 4 people that have to score higher than H, meaning H cannot be first, second, third, or fourth. Likewise, now I has 1, 2, 3, 4, 5 people scoring lower than him, so that means that I cannot be fifth. G now has 1, 2, 3, 4 people that he's scoring higher than, meaning G cannot be sixth. And we see that J now has 1, 2 people scoring lower than him, so that means that J cannot be 9th or 8th. All right, on to rule number 5. H scores higher than N. So H to the left of N, that means N cannot be first, and H cannot be 9th. And we can now combine rule number 5 to our large chain. H is to the left of N. So we see that N has 1, 2, 3, 4, 5 students that score higher than him. So that means N can't be first, second, third, fourth, or fifth. Likewise, since we've added yet another person scoring lower than I, that means I cannot be fourth. The same goes for G. So since we have 1, 2, 3, 4, 5 after G, that means G now can't be fifth. Same goes for J. J now has 1, 2, 3 things after it, meaning J can't be seventh. We now have 1, 2 things after M, so M cannot be ninth or eighth. And now we can go to rule number 6. K scores higher than both F and L. So we have K scoring higher than F and L. So that means that F and L cannot be first. That means that K cannot be eighth or ninth. And now we can add this to our larger chain. So we have K is to the left of F and L. Okay, so that means that F and L both have 1, 2, 3 people to the left of them, meaning F and L cannot be second or third. We see that I has 1, 2, 3, 4, 5, 6, 7, 8 students that score lower than him. That means that I cannot be third and I cannot be second, meaning the only place that I can show up is first. We know that G now has 1, 2, 3, 4, 5, 6, 7 students to the right of it. So that means G cannot be fourth or third. So that means that the only place that G can go is second. We see that the only students that can be third are either J or K. And we see the only students that could possibly be last are the ones in the chain that have nothing after them. So that's F, L, and N, because remember we've placed all 9 students in the long chain. So that's F, L, or N. And those are basically all the deductions we can make. So, as you can see, it's a lot easier for us to have written out this game linearly because having all of these not deductions was going to make the game in the previous way we had set it up in the grouping game a lot more chaotic. So remember, sometimes it's okay to restart your game if you realize once you get to the rules that there's a better and more efficient way to draw out your setup. All right, so we've drawn our setup, our rules, and our deductions. Let's go ahead and hit the questions.